Hello, everyone. Welcome to the podcast. Today, we're talking about how technology is changing fleet management and how platforms like FleetStack are helping businesses manage their vehicles more efficiently.
Absolutely. From real-time tracking to better operational control, fleet management software is becoming essential for modern businesses. In this episode, we'll explore how FleetStack simplifies fleet operations and improves overall efficiency.
But before we get completely into the technical weeds today, I want you to start off by just taking a second to imagine something.
Okay.
Imagine having like a very specific, almost science fiction level superpower.
I'm listening.
So you pull your smartphone out of your pocket right now. You tap the screen, and you have this immediate ability to track thousands of commercial vehicles moving across the globe in real time.
Right.
Then you get this critical flashing alert. One of those heavy-duty trucks has just been stolen from a depot.
A total nightmare for any fleet manager.
Exactly. But with the tap of a single button on your personalized dashboard, you remotely shut down that stolen truck's engine from 1,000 miles away.
Just stopping it dead in its tracks.
Yes, stopping it completely. And then, and this is the crazy part, take all of that highly advanced enterprise-grade technology and imagine using it to instantly launch your very own fully branded software business.
Right, your own business.
Yep, complete with your custom domain name, your company logo, and native mobile apps sitting right there in the Apple and Google app stores.
Okay, that sounds big.
And doing all of that without writing a single line of code.
See, it sounds like the premise of a tech thriller.
Yeah.
Or maybe the pitch for a Silicon Valley startup that just secured, I don't know, $50 million in venture capital.
Right, it really does.
But as someone who deals with fleet operations every day, I know the reality is that the architecture to do exactly that is already fully mapped out. It exists today.
It does.
And it is surprisingly accessible. Which brings us to the core mission of today's deep dive.
Exactly. Today, we are unpacking this massive, incredibly dense. Now, for some quick context for you listening, FleetStack is a market-leading, self-hosted GPS tracking platform. It's essentially the silent engine running behind the scenes for logistics companies, public transport networks, and private fleets all over the world. Yes, the software-as-a-service subscription model that has just completely taken over the tech industry. This text is fundamentally about reclaiming total data ownership.
Reclaiming the keys.
Exactly. It outlines how businesses can escape those endless, creeping monthly fees and take the power back into their own hands. And as we explore this together today, we invite you to think about how this paradigm shift doesn't just apply to trucking and logistics.
Right, it's bigger than that.
It applies to how we all interact with the digital tools we use every single day. Are you renting your digital life, or do you actually own it?
Okay, let's unpack this, because the cost dilemma seems to be the main catalyst for this entire rebellion.
It really is the driving force.
To really grasp the magnitude of what FleetStack is attempting to disrupt, we have to look closely at the financial trap of traditional fleet management software.
The SaaS trap.
Right. Based on the industry data in the source material, the standard right now for cloud-based GPS tracking is essentially a permanent subscription toll booth.
That's a great way to put it.
If you want to track a vehicle, you are typically paying anywhere from $5 to $20 per vehicle every single month to a third-party vendor.
Which is exactly the pricing model the SaaS industry relies on. It's the absolute lifeblood of cloud software valuations.
They want that predictable, recurring revenue.
Right. And at first glance, to a lot of business owners, that doesn't sound inherently malicious. It just sounds like the standard cost of doing business today.
You want the service, you pay the monthly fee.
Sure, if you think about it through the lens of, say, a local family-owned plumbing company, maybe they have 3 service vans driving around town.
Right, paying $15 or even $60 a month to keep an eye on those 3 vans.
The owner probably doesn't even notice that line item on the corporate credit card. It's a rounding error.
But you have to scale that up to understand the financial bleed this document is addressing.
Right.
Because as a fleet manager, I can tell you, imagine you aren't a local plumber. Imagine you are the operations director for a regional logistics firm managing 500 delivery trucks.
Or a national freight carrier with a fleet of 1,000 active vehicles.
That is where the math becomes absolutely
It
brutal.
really does.
If you have 1,000 trucks and you are paying that upper end of $20 per vehicle,
That's $20,000 a month.
every single month, that is nearly $250,000 a year, simply for the privilege of seeing your own trucks on a digital map.
It's staggering when you look at the annual numbers.
It becomes a massive, linear, never-ending bleed on the operating budget. As your company succeeds and your fleet grows, your software penalty grows right alongside it.
It is the literal definition of death by 1,000 subscriptions.
Death by 1,000 subscriptions. That perfectly encapsulates the pain point I hear from operators all the time.
You see how FleetStack executes their counter strategy. They completely throw the monthly subscription model out the window.
Completely.
Gone. Instead, they sell a one-time, lifetime software license.
Just once.
Just once. For that single flat fee, you are granted unlimited vehicles,
Unlimited.
unlimited user accounts, and full API access. Zero hidden recurring fees. You pay it once, and the software is yours.
But I have to admit, when I first read that as someone in the industry, my immediate reaction was skepticism.
Oh, of course.
How does a software company survive without bleeding their customers monthly?
What's fascinating here is the profound business psychology behind this pricing model. It isn't just a marketing gimmick. It fundamentally changes how a company's chief financial officer views technology.
How so?
Well, in corporate finance, there's this constant battle between OpEx, operational expenditure, which are your ongoing daily costs like subscriptions, paper, electricity,
Right.
and CapEx, or capital expenditure, which are your major long-term investments. Traditional SaaS forces software to be an OpEx, a never-ending bill that you can never pay off.
It's just rent.
Exactly. FleetStack shifts the software back to a CapEx.
Meaning, you buy the software infrastructure the exact same way you buy a physical forklift for your warehouse floor.
Precisely. You evaluate the cost of the forklift, you purchase it, you maintain it, and it becomes an asset that generates value for your company for a decade.
And with this lifetime license model, once that initial capital cost is recovered.
Which, for a large fleet, would happen in mere weeks compared to those SaaS fees.
Right, tracking every new vehicle you add to your fleet from that day forward is essentially free.
It breaks the entire dependency cycle that massive SaaS companies rely on for their billion-dollar market valuations. It treats software as a permanent utility rather than a rented luxury.
It's a total rejection of the Silicon Valley playbook.
It really is.
It becomes incredibly apparent that escaping the monthly fee is only half the battle.
Right, there's a lot more to it.
The other half is about control. And that brings us to the highly sensitive issue of data sovereignty and who actually holds the keys to the castle.
This is where the technical architecture of FleetStack really shines because it directly addresses the inherent risk of the cloud.
Right.
When we talk about the cloud, we have to remember that there is no magical cloud, it's just someone else's computer.
Which is a terrifying thought when you realize what kind of data we are talking about here.
Exactly.
Because when you are tracking a commercial fleet, you aren't just sending arbitrary, harmless data to someone else's computer.
Yeah.
You are broadcasting highly sensitive, proprietary corporate intelligence. You are mapping out the exact daily routes of your drivers.
You are pinpointing the exact geographical locations of your clients' hidden warehouses.
You are logging the exact hours when your vehicles are parked, unguarded, and most vulnerable to theft.
And in a traditional SaaS model, all of that operational gold is sitting on a third-party vendor servers.
You are completely outsourcing your security.
Yes, and you are being forced to blindly trust their internal access policies.
If we connect this to the bigger picture, we are living in an era of massive, catastrophic data breaches.
Every other week, it seems.
Hackers aren't just targeting credit card numbers anymore. They're targeting logistical data, supply chain vulnerabilities, and corporate movement patterns.
By relying on a generic SaaS provider, you are putting your company's most sensitive operational data into a massive honeypot alongside thousands of other companies. They provide the software, but you host it.
The manual guides users to install the platform on their own dedicated Windows server or inside their own secure AWS instance.
You, the user, own and control the Microsoft SQL Server database where every single GPS coordinate is permanently stored. FleetStack, as a company, has zero access to it.
Your data physically resides on your infrastructure.
Yes.
But let me push back on that for a second as a practical operator.
Okay, go for it.
The manual suggests hosting this on AWS. AWS is Amazon.
Right.
Isn't that still just someone else's computer?
How is putting your data on Amazon's cloud any more sovereign than putting it on a generic SaaS provider's cloud? That is a brilliant distinction to make, and it gets to the heart of the difference between renting software and renting raw infrastructure.
Okay.
When you use a SaaS product, the vendor controls the application, the database, the security protocols, and who has access to the backend. You are just renting a login screen.
Right. I just get a username and password.
Exactly. But when you use infrastructure as a service, like AWS, you are essentially just renting bare metal. You are renting a blank hard drive and a processor in Amazon's data center.
So I'm building the house on their land.
Yes.
Yeah.
You install the operating system, you configure the firewalls, you hold the master encryption keys. Amazon provides the electricity and the internet connection, but they cannot look inside your database without breaking massive, federally regulated compliance laws.
Because I control the perimeter.
You control the perimeter.
Ah, okay. That makes a lot of sense. The sovereignty comes from holding the actual encryption keys and controlling the database layer, not necessarily owning the physical plastic and silicon the server's made of.
Exactly. And that concept of data sovereignty is absolute music to the ears of anyone working in high-stakes industries. The source text actually provides a gripping, concrete example of this.
The armored transport sector.
Yes. The armored car scenario is where this technology moves from being an administrative tool to a life-or-death security apparatus.
Think about companies whose entire business model revolves around moving physical cash, gold bullion, or highly classified documents.
For them, security isn't just a priority, it is the entire product.
The idea of keeping their real-time routing data on a public, multi-tenant third-party server isn't just uncomfortable. It is a massive, non-negotiable security violation.
And with the self-hosted nature of FleetStack, those armored transport companies bring the entire operation inside their own walls. They use strict SSL encryption to secure the data in transit from the truck directly to their own private server.
But the real power is how they can utilize the software's geofencing capabilities in a high-security context.
Oh, this part is fascinating.
They don't just use it to see where a truck is. They use it to define a highly specific, restricted digital corridor on a map.
The digital corridor concept. According to the blueprints in the manual, dispatchers can literally draw a polygon on the map that outlines the exact route the armored truck is permitted to take.
Right.
So say they are moving cash from the Federal Reserve to a commercial bank. They draw a route down the highway, maybe giving the driver a 2-block buffer zone in case of a detour.
A tiny margin of error.
Exactly. And if that truck deviates from that approved route by even a single city block outside that polygon, or if it stops for more than 30 seconds in an unauthorized zone,
An instant alert is triggered on the dashboard at headquarters.
it immediately signals a possible hijack or a driver under duress.
And the dispatchers aren't waiting for a phone call that might never come. They are reacting to automated, irrefutable location data that is processed securely inside their own private network.
Completely hidden from the outside world.
Here's where it gets really interesting, though. Because receiving an alert about a hijacked armored truck is one thing. But as an operator, I want to know, what can you actually do about it?
Right, the intervention part.
This brings us to the section of the manual, detailing the platform's active management features. We aren't just talking about passive observation anymore.
No.
We are talking about robust, physical intervention from a digital interface, the remote immobilization feature.
It is a profound level of asset control. That if a vehicle is equipped with compatible hardware typically wired directly into the ignition system,
Right.
a fleet manager doesn't have to helplessly watch a little digital dot move away on a screen while they wait for the police.
They can initiate a command directly from the web dashboard or their mobile app to remotely kill the engine.
Describe the visceral feeling of that for a second. You're sitting at a desk in Chicago. Your truck is being stolen in Miami. You click a button with your mouse, and 1,000 miles away, the software sends a secure protocol over the cellular network to the tracker hidden under the dashboard.
That tracker triggers a physical relay to cut the ignition circuit.
The stolen asset is literally stopped in its tracks. The thieves press the gas pedal, and absolutely nothing happens.
It completely flips the power dynamic of theft.
It really does.
And from an operational standpoint, the platform extends this level of security to other vulnerabilities as well. For example, the text details sensor integrations that can monitor fuel levels in real time.
Fuel theft is a massive, underreported drain on logistics companies.
Huge. Imagine a truck parked overnight at a rest stop. The driver is sleeping in the cab. The engine is off.
Okay.
But the system detects a sudden, rapid drop in fuel volume in the tanks
It immediately fires off an alert to the dispatcher.
because someone is currently siphoning 100 gallons of expensive diesel out of the tank in the dark.
The system catches the theft in progress, allowing the dispatcher to wake the driver or call local authorities before the thieves empty the tank.
But as I kept reading through the manual, I realized it's not all just cops and robbers. What really caught my eye was how the software handles the everyday, grinding reality of fleet maintenance.
Ah, the predictive analytics.
Yes.
This is where the platform moves from being a reactive security tool to a proactive financial asset.
Traditionally, fleet maintenance is entirely reactive. You drive a truck until a dashboard light comes on, or worse, until something physically breaks and the truck is stranded on the side of a highway.
Which results in towing fees, lost cargo time, furious clients, and massive repair bills.
Yeah, exactly. It's the worst-case scenario.
But the FleetStack knowledge base details how they utilize continuous telemetry pulled straight from a vehicle's OBD2 port.
Now, for you listening who aren't mechanics, the OBD2 port, or onboard diagnostics port, is that little hidden plug under your steering wheel that the dealership uses to figure out why your check engine light is on.
Right, they plug a computer into it to read the engine's internal codes.
FleetStack essentially puts a permanent remote stethoscope on that port. The software isn't just looking at GPS coordinates.
It is reading the microtrends of the engine's performance while the truck is driving down the highway.
It's a constant stream of diagnostic data.
The system can detect subtle voltage patterns in the electrical system to warn a manager that an alternator is beginning to fail.
It notices that the voltage is dropping slightly every week.
It flags this anomaly, potentially weeks before the battery actually dies and strands the driver.
Or it can track the fuel consumption metrics against the engine load over thousands of miles.
Yes, so if it notices that a specific truck is suddenly bringing 15% more fuel to haul the same weight as the rest of the fleet,
It automatically flags that the truck is operating below efficiency standards and requires an engine tuning or a tire pressure check.
it's essentially replacing the mechanic's intuition with hard, actionable data.
And speaking of actionable data, the document spends a lot of time on how geofencing isn't just for security, but for pure, ruthless efficiency. Let's look at the warehouse application they describe.
Geofencing for operational efficiency is a massive force multiplier. The concept is simple, but the execution yields incredible results.
You draw a virtual boundary around your warehouse, but you extend it out, say, 3 miles in every direction.
So you have a massive delivery truck coming in. The exact second that truck crosses that invisible 3-mile perimeter,
The FleetStack software automatically triggers a localized alert to the warehouse floor managers.
they know the truck is exactly 7 minutes away.
Right.
And in those 7 minutes, they can prep the specific loading dock, they can get the forklift in position, and they can have the paperwork ready.
And you have to do the math to see why this matters to a fleet manager.
Yeah, walk us through that.
It might only save 5 or 10 minutes per delivery, but if you are a major distribution center handling 200 deliveries a day, shaving 10 minutes off the turnaround time of every single truck saves over 30 hours of labor and idle time every single day.
Wow.
Multiply that across a 300-day working year. It compounds into massive, tangible annual savings. You are drastically reducing idle fuel burn and bottlenecking at the docks.
You can use geofencing to monitor driver behavior in specific residential zones. You draw perimeters around neighborhoods and set custom speed limit rules for those polygons.
So if a bus driver exceeds 25 miles per hour inside a residential zone, the transport director gets a notification.
It ensures that speed limits are strictly adhered to where children are present, which is a huge liability and safety priority.
The scope of these features is massive, which makes this next part of our deep dive so incredibly surprising.
I know exactly what you're going to say.
Because up until now, we've been talking about this software purely as an operational tool to manage your own internal fleet.
Right.
I hit a section that completely flipped the script.
The white label capabilities.
The revelation here is mind-blowing. FleetStack isn't just designed to track internal fleets. It is explicitly, intentionally built to let users start their own GPS tracking businesses.
It is essentially brand hijacking, but it's a hijacking that is fully encouraged and supported by the original developer.
They hand you the architecture, and they tell you to go sell it as your own.
It represents a fascinating democratization of enterprise technology. Think about the traditional barriers to starting a SaaS company from scratch.
It's an incredibly daunting endeavor.
You typically need millions of dollars in venture capital funding just to get off the ground. You need to spend years in research and development.
You have to hire massive engineering teams to build the back-end database, the web interfaces, the API structures, the mobile apps.
You have to debug the software, test the hardware integrations, and build the server infrastructure.
It's a massive, impenetrable wall that keeps everyday entrepreneurs completely out of the software business.
But FleetStack completely bypasses those barriers. A system integrator, an IT consulting firm, or even just an ambitious entrepreneur can purchase that one-time.
They get access to a mature, road-tested software architecture.
They can then turn around and resell this tracking service to their own local clients, say the local plumbing companies, the taxi fleets, the school districts in their county.
And because they aren't paying any ongoing per-vehicle fees to FleetStack, the entrepreneur keeps 100% of the ongoing subscription revenue they generate from their clients.
It's an incredible loophole. You are essentially buying a tech business in a box.
But we really need to pause and explore the economics of this. The margins must be insane.
They are.
If an entrepreneur buys the license, sets up a server, and then signs up 5 local landscaping companies that have 20 trucks each.
That's 100 vehicles.
Right. If the entrepreneur charges them $15 a month per truck, which is cheaper than the big corporate SaaS competitors, that entrepreneur is pulling in $1,500 a month in recurring revenue.
And their only ongoing cost is whatever they pay Amazon to host the server, which might be $100 a month.
The software license is already paid for. They hit profitability almost instantly.
Which is completely unheard of in the traditional venture capital-backed software startup model, where companies often burn cash for 5 to 10 years before seeing a single dollar of profit.
It's one thing to slap your logo on a web login screen. That's basic white labeling that we see everywhere.
Right.
But having your own native apps in the iOS and Android app stores, that is the ultimate credibility marker for a software company.
When a client can search for your company name in the App Store and download your app, it instantly validates your business.
Through a tool called FleetStack Studio.
The no-code app builder. It's a remarkably streamlined process designed for users who have absolutely no programming experience.
I was reading the step-by-step instructions and I was just marveling at it.
User simply logs into this FleetStack Studio interface. They input their custom server URL, the domain where they hosted the backend.
They paste in a Google Maps API key so the app can render the tracking maps.
They paste in a Firebase key.
Now, what exactly is a Firebase key for those who aren't app developers?
Firebase is a platform developed by Google. In this context, it is the service required to send push notifications to smartphones.
Okay.
When that geofence alert goes off or that engine kill switch is activated, Firebase is the infrastructure that actually makes the user's phone buzz in their pocket with an instant notification.
By pasting their own key in, the entrepreneur ensures the notifications are coming from their system, not FleetStack's.
Got it. So they plug in these basic keys, they upload their custom company logo, and they select their brand colors.
And then they literally just click a button that says build.
What is actually happening behind the scenes when they click that button?
Within minutes, the FleetStack Studio server automatically compiles all of those assets. Compiling is essentially the process of taking the raw source code, injecting the entrepreneur's custom colors, logos, and API keys, and translating it all into a format that a smartphone can actually install and run.
It generates the raw application files.
Right. For Android devices, it spits out an APK file. For Apple devices, it generates an IPA file. These are the required native package formats.
And critically, these files are fully branded and entirely devoid of any FleetStack branding in the code.
The user can then take those raw files and publish them directly to the Google Play Store and the Apple App Store under their own developer account.
So, to the end user, the landscaping client who is paying a monthly fee to use this system, they download an app named Smith Logistics Tracker.
They see the Smith Logistics logo on their iPhone home screen, and they assume Smith Logistics spent $500,000 developing proprietary software.
They have no idea they are running on the FleetStack backbone.
It's brilliant. It's the ultimate smoke and mirrors that allows small businesses to punch way above their weight class.
But, and this is a very big but, we need to take a step back and look at the reality of what is being promised here.
Yes. The IT reality check.
Exactly, because reading through the marketing materials, you see a lot of incredibly optimistic language. The tagline for FleetStack, proudly stated in the document, is "We make it easiest, just deploy."
They claim you can execute a one-touch installation in under 5 minutes.
And I have to say, looking at the sheer volume of technical requirements later in the manual, I find that 5-minute claim highly suspect.
This raises an important question, doesn't it? What is the actual day-to-day reality of becoming your own IT department?
Because that is the trade-off.
When you enthusiastically abandon the traditional SaaS model to escape the monthly fees and reclaim your data, you are simultaneously taking on the total, unfiltered responsibility for server maintenance, uptime, and security.
You can no longer just submit a support ticket to the cloud vendor, complain that the system is slow, and go to sleep while their engineers fix it.
You're the vendor now. The buck stops with you.
And the technical specifics outlined in the manual are rigorous. The manual makes it clear you can't just run this on an old laptop in your basement.
It mentions setting up something called an AWS EC2 T2.medium instance with at least 4 gigabytes of RAM.
What exactly does that look like for a beginner who has only ever used a web browser?
Right, it recommends starting with a T2.medium instance. In the world of Amazon Web Services, an EC2 instance is simply a virtual computer that you are renting by the hour.
A T2.medium is a specific size of computer. It has 2 virtual processors and 4 gigabytes of memory.
It's not a supercomputer, but it's robust enough to handle the constant rapid-fire database writes required by hundreds of GPS trackers.
But spinning up the server is only step 1. The real challenge comes with managing the network traffic.
And this isn't just basic web hosting where you buy a domain name and upload some HTML files.
Far from it. This is where the massive complexities of IoT, the Internet of Things, really come into play.
A typical web server, like if you were hosting a WordPress blog, only needs TCP ports 80 and 443 open.
Port 80 handles standard HTTP web traffic, and 443 handles secure HTTPS traffic.
That's easy. Almost every server has those open by default. But FleetStack isn't just serving web pages.
It is ingesting raw, continuous GPS telemetry data from hundreds or thousands of external hardware devices out in the field.
To allow that raw data into your server, you have to manually open a custom range of firewall ports, typically between 5,000 and 5,500.
And the text gives some very concrete, unforgiving examples of this. It mentions specific hardware protocols.
If you are a fleet manager and you buy a batch of Concox brand GPS devices, the manual notes they communicate specifically on port 5023.
If you buy a Teltonica device, it uses port 5027.
So imagine a scenario where an ambitious entrepreneur gets the server running, buys 100 Teltonica trackers, installs them in client trucks, but they fail to properly configure their AWS security group to explicitly open port 5027. What happens?
The telemetry data hits a brick wall.
The tracker out in the truck is desperately trying to send its location over the cellular network every 10 seconds, but your AWS firewall sees unrecognized traffic trying to enter on port 5027 and actively blocks it.
Assuming it's a cyber attack.
The data is dropped instantly. The end result is that your beautiful custom-branded map stays entirely blank, and your new clients start calling you furiously, demanding to know why the system they are paying for is broken.
And that's just the networking side. The security and disaster recovery requirements are equally heavy.
Owning your own data means you are solely responsible for protecting it.
You must secure the communications by generating Let's Encrypt SSL certificates. The manual guides you to use a tool like WinAcme to do this.
And then you have to dive into the Internet Information Services, or IS, manager in Windows to bind those certificates to your domain.
For a non-technical person, opening ICE Manager looks like trying to pilot a commercial jet.
It requires a fundamental understanding of Windows Server administration. An SSL certificate is what gives your website that little padlock icon in the browser, ensuring the data between the user and the server is encrypted.
WinAcme is a tool that automates getting those certificates for free.
But if you misconfigure the binding in ISA, your users will get a massive, scary red warning screen from Google Chrome saying your site is unsafe.
Which instantly destroys trust with your clients.
And crucially, there is the matter of the Microsoft SQL Server database. This database holds every single route, every user account, every alert history.
The manual is very clear, almost warning the reader. You must automate your SQL database backups.
Let's walk through a disaster scenario. Say an entrepreneur has 50 clients running on their server. One night, their AWS instance suffers a catastrophic hardware failure.
Or worse, a ransomware attack encrypts their entire server.
And they realize they never set up automated offsite backups.
It's the ultimate nightmare scenario.
It's all gone.
Yeah.
Every single piece of your client's data is gone forever. All the historical routes, the user logins, the geofences.
FleetStack does not have a magical hidden cloud backup waiting to rescue you. Because of the data sovereignty model, they have no access to your system.
You demanded ownership of the data, which means you own the absolute consequences of losing it.
You would have to rebuild the entire business from scratch and try to explain to 50 angry clients why their data vanished. It is a massive burden of responsibility.
Which actually leads beautifully into the troubleshooting section of the manual.
Yes, because reading through the common errors that server admins face provides a hilarious and sometimes painful look at the mundane headaches of this industry.
It perfectly contrasts the high stakes of data loss with the absolute silliness of day-to-day IT support.
The troubleshooting section is an absolute goldmine of operational realities. It perfectly illustrates the gap between the high-tech paranoia of the end user and the gritty, mundane reality of the systems administrator.
It really does. My favorite example from the text is when a GPS tracker suddenly goes offline.
Oh, the signal jammer assumption?
The manual notes that a paranoid fleet manager will instantly assume the worst-case scenario. A truck carrying expensive electronics stops updating on the map, and the client thinks highly sophisticated thieves have targeted their cargo and are using a military-grade GPS signal jammer to cloak the truck.
They are ready to call the FBI.
But the text reveals that the reality is almost always completely mundane. It's incredibly rare to encounter a signal jammer.
Usually the device is offline because the physical SIM card inside the tracker simply ran out of prepaid data.
The client forgot to pay their cellular bill.
Or, when the installer was configuring the device via text message commands, they made a tiny typo in the APN, the access point name, which results in a frustrating GPRS link down error.
The tracker works perfectly, but it simply doesn't know how to connect to the local AT&T or T-Mobile cellular network because of a typo.
Or how about the blank map issue? A client logs into their portal, sees a totally blank gray box where the street map should be, and assumes the entire server architecture has collapsed.
They think the database is corrupted.
The reality: you, the admin, probably just maxed out your free Google Maps API tier quota, and Google temporarily cut off your access to the map tiles until you put in a credit card.
It's almost always a billing issue, not a cyber attack. A dispatcher goes to audit a delivery truck's route from yesterday because a customer claimed a package wasn't delivered.
Right.
They load up the historical playback on the map, and instead of a straight line moving smoothly down the highway, the truck appears to be breaking the laws of physics.
The digital dot is jumping wildly across the map, looping backward through time, showing the truck in two places at once. It looks like a glitch in the matrix.
And the cause of this temporal anomaly is entirely rooted in how global servers handle time.
Hardware GPS device physically installed in the vehicle must be strictly configured to UTC Coordinated Universal Time with a 0 offset.
Right. But let's say an installer in New York accidentally sets the hardware tracker to their local time zone, Eastern Standard Time, which is UTC minus 5 hours.
The tracker records a location at 2:0 p.m. local time and sends that timestamp data to the server.
But the FleetStack server is programmed to assume all incoming raw data from hardware is in UTC. So the server receives it and then applies another time zone offset on top of it to localize it for the web dashboard.
Exactly. It applies a double time zone offset. So the server receives a data point, incorrectly adjusts it again, and suddenly logs an event that happened at 2:0 p.m. as happening at 9:00 a.m. in the database.
When the software tries to draw a chronological line connecting those dots, it completely scrambles the sequence.
The line draws forward to 2:00 p.m., then wildly shoots backward across the map to a dot logged at 9:00 a.m., resulting in a playback that looks like the van is violently looping through time.
It's a perfect example of how one tiny misconfiguration in a remote piece of hardware can create absolute chaos on the software side.
It highlights the very steep learning curve of self-hosting a telematics platform. You aren't just dealing with software. You are dealing with the messy intersection of software, cellular networks, physical hardware, and human error.
But to be fair to FleetStack, they don't just hand you the executable file and abandon you to the IT wolves.
They provide a very substantial safety net. They understand that while their software is powerful, the barrier to entry is technical literacy.
To lower the financial anxiety of taking this leap, They offer a 7-day money-back guarantee, allowing you to essentially test drive the installation process risk-free.
If you realize within a week that configuring ISI and AWS is too much for you, you can back out.
Furthermore, they have cultivated an active community forum where users share configurations, XML files, and solutions alongside deeply detailed documentation.
And manual links to a whole library of YouTube tutorials that walk you through the really intimidating stuff step by step.
Like exactly how to generate those Let's Sell certificates without breaking your server, or how to properly configure the FleetStack Studio to build your white label mobile apps.
But the safety net that truly stood out to me, the one that makes this entire self-hosted endeavor actually viable for a small business, was what I like to call their red phone option.
The dedicated WhatsApp engineering support line.
Yes. The text notes that for mission-critical server crashes, you don't have to fill out a generic web form and wait 48 hours for an automated email reply from a Tier 1 support agent who just reads from a script.
You have a dedicated WhatsApp line to directly ping their engineering support team, and it's available even outside normal business hours.
That level of unfiltered, direct access to the actual developers is practically unheard of when you are dealing with massive corporate SaaS providers.
It shows they fundamentally understand the incredibly high stakes of the logistics industry. If your tracking server goes down at 3 a.m., your trucks stop moving, your dispatchers are blind, and you bleed money by the minute.
Having a developer on WhatsApp to help you troubleshoot a database corruption is incredible.
It's a vital lifeline for anyone who is taking on the burden of server management. It provides the psychological peace of mind necessary to make the leap from rented, comfortable cloud software to a self-hosted platform.
It bridges the gap between total independence and total isolation.
So let's pull all of these threads together.
It is a comprehensive rebellion against the dominant SaaS subscription model.
It offers businesses the opportunity to secure true enterprise-grade features like predictive engine analytics, remote vehicle immobilization, and complex operational geofencing for a single flat fee.
It grants absolute data sovereignty by putting the SQL database securely on your own servers, away from the prying eyes of third-party vendors.
And incredibly, it hands ambitious users the actual keys to white label the entire architecture, allowing them to bypass venture capital and launch their own branded tracking business overnight.
Provided, of course, they're willing to walk the technical tightrope of managing a live production server, configuring firewalls, and dealing with time-traveling vans.
It really is a profound offering, and it raises an important, broader question.
So what does this all mean?
As corporate data privacy becomes an increasingly critical issue worldwide, and as consumer and corporate subscription fatigue finally reaches a breaking point, could this buy it once, host it yourself model pioneer the eventual collapse of the modern SaaS empire?
Imagine a near future driven by edge computing, where entirely private, localized servers running quietly in a utility closet replace the massive, centralized cloud providers entirely.
Look around at all of the digital tools in your life right now. Your cloud storage, your creative software, your business logistics platform.
How much are you paying every month just to rent access to your own data?
And more importantly, which of those rented tools are you ready to finally own?